So why are pedostatics so important? This shows you the effect of density altitude, which is a crucial factor for most pilots, causing many accidents every year, especially at high altitude on hot days, high gross weights. So you can see here the takeoff distance increase for a normal airplane at 6,000 feet from sea level, more than doubling. And this can lead to a tragedy in the traffic pattern because the pilot confuses a fast airspeed, which is his true airspeed, as he looks outside, relative to the indicated airspeed, which he should be paying attention to.
You're descending into a mountain valley, intending to land on a short runway, but you don't have much mountain flying experience. The field elevation is 6,000 feet, and the density altitude is 8,000 feet. It's windy and bumpy. Entering the downwind leg, you feel like you're going too fast, so you reduce power while holding altitude. Still, your ground speed seems high, and you inadvertently overshoot the turn from base to final. You feel like you're low, and you've heard that it's not smart to use steep bank angles in the traffic pattern. So you keep your turn shallow and use the left rudder to point the nose at the runway. Then, before you know it, the airplane shudders, stalls, and starts to spin. You're unable to recover.
So, you could see what happened was the perception of high ground speed caused the pilot to think he was going too fast, when he really should have been focusing on his indicated airspeed, which, if you remember, the test day indicated speed for stall is the same as the standard day, any day, whereas your true airspeed is going to increase substantially when the density altitude is much higher. So the pilot pulls back on the power, maintains back pressure on the stick, and does not focus on his low indicated airspeed. Then to make matters worse, as he's turning, he steps on the rudder instead of increasing the bank. And increasing the bank, of course, is a dangerous thing to do, but it looks dangerous, and that's why the pilots don't do it. They step on the rudder instead. Well, what this does is, of course, it tends to blank out the low wing and puts you in a departure situation for a stall. And actually, it's not a stall, it's a stall spin entry, which means that instead of a few hundred feet to recover, you need 500 to 1,000 feet to recover, which you normally don't have in the traffic pattern. So density altitude is a very serious thing, and that's why pedostatics, we keep returning to basics in the flight test class.